for the sake of the recording, for the young woman who's not here, I know I'm going to repeat myself, but remember, Friday is when your focus activities are going to be due. Thursday is going to be your exam. Are there any questions about the exam itself? Does anybody want me to list what's going to be on the exam? Okay, so remember, what's that? Oh, I thought you were asking. Okay. We're going to be looking at frequency tables, histograms, box and whisker plots, cumulative frequency, and measures of central tendency, which means what? Mean, median, and mode. Okay. And it's on Thursday, yes. Okay. Will you be here Friday? Okay. Then ideally, if you could come in the morning to do it. If not, then we'll do it during sixth period. Okay. All right. So if you go ahead and look over your resources, the notes, things of that nature, I think you're going to be just fine. Remember, the cumulative frequency homework is going to be due tomorrow. Hopefully, you don't have any issues with it. Looks like a lot of people did really well on the exit ticket we just had. Okay. So let's move on. Our next unit. And about 20 minutes. We'll probably get decently far. Let's talk about standard deviation. The standard deviation is a measure of how spread out numbers are. So a lot of times you're going to see it defined as just a measure of spread. That's really what it is. It's a numerical value that simply describes how far apart or how close the values in your data set are going to be. Like, for example, if I were to have a data set like, let's say 2, 3, 3, 5, 7, versus a data set of, I don't know, 2, 10, 10, 21, 35. Okay. Let's say we have two different sets of data. Standard deviation is simply a descriptor. It's a numerical value designed to give you an idea about how close or how far apart the elements in your set are. So which one of these do you think, the top one or the bottom one, would result in a smaller standard deviation? The top one, because those numbers are relatively close to each other. They're very close. But the numbers in the other set, they're much further spread out, so you would expect to get a larger standard deviation there. And that's all it is. It's a great tool. There's a formula that goes along with it. But I do want to caution you, how many people have had the opportunity to look through the website, all that information that I posted? Okay, especially the rubric. Be looking at the rubric for how I'm going to be grading your internal assessments, because one thing it says about the mathematical strategies, the key word is relevant. And standard deviation is a great strategy. It's very easy to go ahead and plug in, but that's the key. It has to be relevant. It has to in some way relate to what you're doing. Like, why did you use standard deviation? Why do you believe that this measure of spread is a good way of analyzing your data? Does that make sense? Okay. It has to be tied directly to it somehow, or otherwise I can't count it as a mathematical strategy. I mean, the rubric, is very, very specific about what it will and will not accept. Okay, and IB is like that anyways. And since I'm talking about it, I've already had one person turn in their IA topic document. Does anybody else have that ready to go? That's okay. When's that due? Due on Tuesday. Due on Tuesday. Remember, we have a 3-day weekend. Okay, so if you haven't gotten that done, just take some time. Bless you. Think about it. This is not set in stone. If you want to change your topic later, can you? Bless you. Yes. Okay, right now I just want to kind of get you thinking about some kind of topic and maybe even how to collect some data, where to go from here. Okay, so let's get back to this. Its symbol is sigma, the Greek letter sigma, and we've seen him before. You remember when I showed you on the calculator? Bless you. Good Lord, you're sneezing so much, everybody's looking at you. Why are you laughing more now than I had you last year? I'm still the same funny guy. It was way too quiet when I said that. Okay. But we've seen sigma before. You remember when I showed you in the calculator, we put in some data, and I went ahead and showed you how to create the box and whisker plot. But then I also showed you how to calculate the 5-point summary, where it gave you all that information. Well, remember, bless you, good Lord. Sigma was one of those. This is going to be the standard deviation we're looking for. Now, the formula is the square root of the variance. Okay, we're going to get to the formula in just a bit, hopefully before you leave today, but if we don't, I mean, that's fine. I'm going to go ahead and walk you through the process first with a real simple example. Okay, the variance is the average of the squared differences from the mean. Okay, so what does mean refer to? That's the average. Okay, so one of the things you're going to be doing here is finding the average for your set of data. To calculate the variance, okay, follow these steps. Now remember, once you have the variance, if you take the square root of that, that is your standard deviation. If you square your standard deviation, then you get back to the variance. Okay, there is a certain notation we use when we talk about these particular concepts. So first, you want to work out the mean. So to find the average, you take the sum total of all your elements, divide by the total number of elements. Okay, that's easy. The second bullet, then for each number, subtract the mean, that average, from each of the elements in your set, and then square the result. Okay, that's what we refer to as the square difference. Then work out the average of those square differences. Okay, so let me walk you through this, make it a little easier. It says you and your friends have just measured the heights of your dogs in millimeters. Because that's something friends do normally, right? Yeah. Okay. Hey, I wonder how tall that dog is in millimeters. Okay. But here we go. The heights at the shoulders, okay, so we're going to the shoulders, are 600, 470, 170, 430, and 300 millimeters. Find the mean, variance, and standard deviation. Okay, well, we're going to use the mean, okay, with those strategies that I just talked about, those steps to find the variance, and we're going to use that variance to find the standard deviation. Now remember, once you find the variance, you take the square root of it, that's the standard deviation. Okay, so let's go ahead and calculate the mean. So I'm going to take all these values, 600 plus 470 plus 170 plus 430 plus 300. Well, I've got 5 dogs here. Okay, so somebody help me out. What's the grand total of all 5 of those? 1,000 what? What? I'm getting 1,970? I thought somebody was saying 800 or something. Maybe I'm old. There we go. Keyword maybe. Okay. 1970 divided by 5. Okay, so what's the average of all the dogs' heights in millimeters? 394. So that one worked out nicely. Okay, so I found the mean. There's the first part. Now what I need to go ahead and do is find the squared differences. That means I'm going to take the original elements in my set from 600 all the way to 300. For each of them, I'm going to go ahead and subtract the average that I just found. So I'm going to go ahead and say, let me write it like this. So I'm going to have 600 minus 394, which is going to give me what? Okay, 206. All right. Now let's find all those differences, and then we'll come back in just a second. So next up was 470 minus 394, which will give me 76. Okay. Then I'm going to take the next one, 170 minus the 394. So this is the first one that's going to end up being what? Negative. In fact, what is it? Negative 224. Now, do you think it's okay that we got a negative? Why? Because remember, what are we about to do to it? We're about to square it. There we go. Okay. So now, let's see, 430 minus 394, which will give me 36. And we've got one more to go, 300, the last element, minus 394, the mean. So I'm looking at a negative 94. Okay. Now remember, there is a formula for all this, but setting up in a table or maybe doing it over to the side so that you can keep track of everything like this, probably not a bad idea, okay, because it might be really easy to make a mistake. So we found the average. I took each of the elements and I subtracted that average. Now I'm going to take all of those. I'm going to square each one. Okay. And I'm going to go ahead and take the total. I'm going to add up all those squared values. Okay. So somebody help me out with this. 206 squared plus 76 squared plus basically 224 squared. Remember, when you square the negative, it becomes a positive anyway, so we can basically ignore that. plus 36 squared plus 94 squared. Radley is absolutely right. We have 108,520. Now, I'm going to take that sum, 108, whoop, put 180, 108,520. Okay, I'm going to take the average of those square differences. So I'm once again going to divide this by 5. This is what we refer to as the variance. Okay, so somebody help me out. 108,520 divided by 5. 21,704. 21,704. Now that's the variance. Okay, but remember, or excuse me, what do we do? Wait, isn't that a point? No, what am I talking about? 108,520. Yeah. Okay. So now, what have I been telling you to do with the variance in order to find the standard deviation? Go ahead and take the square root of it. Okay. So 21,704. Okay. Let's see here. I'm going to go to calculate, if it will let me. Square root 21,704. Whoop. Didn't take the 2. 21,704. I'm going to push enter. So I'm getting a standard deviation about 147 point, let's say 32. Okay. 147.32. There we go. That's a descriptor. That's the standard deviation. Okay. So the square root, 21,704. And I completely just blanked on the number, 147.32. 147.32. That is my standard deviation. Okay. All right. Well, I would say that's a relatively high number. So without even looking at the set of data, what would you expect to see once you did view it? Would you expect the numbers to be pretty different, pretty far apart, or much closer together? I expect their measure of spread to be much greater. Okay. There's a vast variety in the 5 numbers that we are looking at. And that's it. That's how you find standard deviation. Okay. Had anybody had experience with standard deviation before? Okay. You didn't understand it until now? So now it works? Nice. Was this problem rough for anybody else? Rough. It's a dog. It's bark. You know, standard deviation, its bark is worse than its bite. Yeah. Oh, it's going to be a long year. Or it's already been a long year, depending on who you're talking to. Okay. So let's take a look at what we have here. So I gave you an example to kind of give you an idea of what standard deviation represents. And now let's actually, go ahead and start the lesson. It measures the deviation between scores and the mean, and is a measure of the dispersal of the data. Okay, it's just a descriptor. The difference between the scores and the mean are squared, and the average of these squares is then found, known as the variance. The square root of the average, this variance, is what's known as standard deviation. Okay, so if I go ahead and square my standard deviation, that gets me right back to what? That gets me right back to the variance. Okay. Now in notation, I believe it's next week when we're talking about normal distribution, the variance is going to come up again, so I'll be bringing that up. But here in IB, we're really not going to do anything with the variance itself other than basically mention it. Okay, it's the standard deviation that we want to take a look at. The larger the standard deviation, the more widely spread the data would be, and vice versa. Okay, so we have population standard deviation. Here's the formula, and there's that little notation, sigma. Okay, so this uppercase sigma right here, that's your summation. What do you think that F stands for? What have we been working on in the past couple of lessons? Frequency. So even if your data is given to you as a frequency instead of the data itself, you're going to go ahead and multiply the frequency times the number of elements that appear at that particular time, whatever it is. Even if you're dealing with class sets, you can take the standard deviation. Okay, so let's go ahead and try another example. The standard deviation for ungrouped data can be found by using this formula. So you'll notice here, this is if we have frequency values. This is if we just have a straight set of data like we were just looking at. The square root of sigma, okay, the summation of the square differences divided by n. Okay, where X is any score, basically any element in your set. Okay, when you see X with a little bar above it, that's your mean, that's your average, and then N is the total number of scores. All right, so calculate the standard deviation for this. 2546756. Okay, do it by hand. All right, well, the first thing I'm going to do, and it doesn't matter if I put these in order or not, I'm just going to go ahead and list them. So I got 2, 5, what do you got? 4, 6, 7, 5, 6. Okay, so I am going to go ahead and take a total, because in order to begin finding standard deviation, what's the first thing I need from the set? Okay, starts with an M or an A, depending on what you say it. The mean. Okay, we need the average. So 2 plus 5 plus 4 plus 6 plus 7 plus 5 plus 6. 35. So that's going to give me 35. Okay, so I'm going to take that sum total, 35. I'm going to go ahead and divide it by, we have how many terms here? 7. All right, so my mean is 5. And this is why I like to generally go ahead and create a table, because it just organizes everything so nicely for you. All right, it's very, very unlikely that you'll make a mistake if you're just randomly doing it on your paper. Okay, so now I'm going to take each one of these 7 scores, and I'm going to subtract the mean that we just found. So 2 minus 5, negative 3. 5 minus 5, 0. 4 minus 5, negative 1. Well, when we're in math, it's negative fun. Hey, math, I'll go back to it. Okay, 6 minus 5, 1, 7 minus 5, 2, 5 minus 5, 0, and 6 minus 5, 1. Okay, so I've got the difference. Everybody okay with how I got those numbers? Now, what am I going to do with those numbers? Yeah, and you see how the table is progressive? First, it allows you to find the differences. Now, some people just like to cut out this middleman right here. If you want to go ahead and take the difference and square it at the same time, please feel free to do that. Okay, there's nothing saying you couldn't. So this one would be 9, 0, 1, 1, 4, 0, 1. Okay, now what's the total of all those? 16. Now, these are the square differences between the elements and the mean that we just found. So I need to take the average of these once again. So I got 16. Okay. Now, by taking the average, remember I'm going to divide this by what? How many elements do I have? 7. Now, if I just did that right there, 16 divided by 7, that would represent the what? Starts with the V. That's the variance. Okay. Once I take the square root of that average, that becomes the standard deviation. Okay. So let's see what that is. The square root of 16/7. Okay. And again, I like to go ahead and use the fraction template here. You don't have to do that. Okay. 16 divided by 7. I'm getting about 1.51. Okay. So about 1.51. That's my standard deviation. And you'll notice that's a pretty low number, especially compared to the one that we just saw. So what's that describing to you about the data? Would the data be relatively close or further away from each other? I'd say they're relatively close. In fact, with such a low standard deviation, there you go. I mean, those numbers are pretty much all really close to each other. Okay. All right, I've got 205. How are we doing on standard deviation? Is this making sense? Does anybody have any questions? Okay. Well, then we'll come in tomorrow. We'll go ahead. We have our next focus activity. We'll go ahead and run through a few more examples with class sets and frequency, and then we will be done. Okay, thank you.